Hello guys, welcome back. In this video, let us understood two important points. One is histogram representation of the data, and second one is summary of a model. So why do we need these two? The first question, that why do we need these two? Why do we need this histogram representation of data? Let's say you have a lot of a data set. In that, some data is related to male and some data is related to female. Now you want to classify that. You want to identify how much amount of portion is related to male and how much amount of data is related to female content. So that you want to classify in order to overcome biasing. During that scenario, visualization is very important. So this histogram representation allows us to visualize our data. So whatever the data that we have in the form of panda data frames, that data we can able to visualize by using in the form of histograms. And the second one, the summary of the model. Let's say you are building a model, or let's say already built model that you take, and now you don't know the internal details, like so how many hidden layers are there, how many input layers are there, and how many output layers are there. So those things you want to understood, or in detail if you want to understood totally how many number of parameters your model is using, that parameters count you want to identify. During that time, the summary model is required. Now in this video we will understood two things, that is if we have a data in the form of a panda data frames, then how to create histogramic representation of the data to see our data is proportioned or our data is distributed among multiple proportions. And the second one is summary of a ML model. To understood this, let's take an example code. This I have already explained in the previous session. This is related to classification, like whether a person can able to survive or not based on the given inputs. You can see here, here the person can able to survive or not. Here the input list I have provided. Based on this data, I'm predicting whether the person can able to survive or not by using our model. This is the model that we previously created, and we trained that model with some data set. That data set is nothing but this data set, iton.csv file data set. Now, first I want to visualize this data set. First, I'm expecting to visualize this data set. Then how can I able to visualize that data set, sir? If you want to visualize the data set, after creating our data set and completed the processing step, I want to visualize the whole data. So that's actually present in the pandas data frame itself. We just picked that data, or we just stored the URL. By using that URL, we read the CSV file and stored in this data. Then we do the required operations, like we remove the unnecessary columns and we fill the missing values, and we even get the categorical data to classify among multiple classifications. Now I want to see, or I want to plot that graph. I want to see the proportion of data, which proportion of data is related to what, how the data is distributed. If you want to see that, then you require this hist, histogram representation. So where our data is in this data variable. So data dot hist of what is the figure size that you want. You can see multiple parameters are there, but now currently I'm specifying only the required parameters. Like I want to see in 13:1 plot, and in order to see the graph, we need to import matplot library. We need to import matplot library. In that pyplot, we need to import. I'm importing it as a PLD, and just to show this data, I'm just writing this plot dot show. So that's it. Now I'm just running this code. You can see pyspace the file name .py. Now it will show me the plot. Now you can observe it was showing me the histogram plots, like based on the trained data, based on the data that I have, or CSV file data that I have loaded on that data. You can see this much proportion is related to survived data, that is a 0, that is not survived, and this much people are survived. 1 represents survived, 0 represents unsurvived or not survived. So these many people are not survived, these many people are survived. And like that, age classification is also there. So like that, in real time you may have bias related to given data, like your model will work only for this, or your model will highly prefer this type of outputs rather than this based on the trained data. So that may happen sometimes in real time. So the balancing of this data is also very important. So you need to remove specific data, like here 300 change related data persons are survived. So you also need to take only 300 change data related to this unsurvived as well. You need to remove the access records which are unsurvived, so that your model can able to predict without bias. So that taken care, we need to take care. So like that, we have multiple parameters, those related bias maintenance also we need to take care in real time. And the second part, so this is related to how to see the data by using this histogramic representation. The second part that we are expecting is we are expecting to see the model. You can see this is the model that we created, right? Yes, we compiled that model here and we trained our model here. Before compiling itself, I'm expecting to see the summary of my model. In detail, you can say the total number of parameters that I am using in this model that I want to see. So during that time, model dot summary is a simple command that you need to use, and just print that summary so that you can able to see that. And I'm rerunning this code so that we can able to see the summary of it, like how many parameters are used. I'm just closing the plots. like what is the input layer, what is the hidden layer, and each layer related neurons and units will be shown. So here I want to, you can see this is the model related summary. Previously we haven't got this, now we got this. Like you can see, the first layer has these many outputs and parameters. These parameters are nothing but what are the parameters that are used in this layer. Either it may be input or output or during processing. And totally the parameters in this layer are used is 576, right? Yes. So how can we able to identify the total number of parameters are used? For input, for taking the input, how many inputs are there? So those all inputs need to be taken by these layers, right? Yes. So let's take the provided dataset, or let's take the sample dataset. You can see 1, 2, 3, 4, 5, 6, 7, 8. So totally 8 number of features are there. In the input, how many features are there? 8 features are there. So 8 into, so totally we have 64 neurons. So each neuron can able to take each and every feature, and each neuron can process the data. So 8 into 64. So totally 512 input as well as the processing neurons will be there in this layer. Coming to output from this layer, again 64 neurons are there. 64 neurons are taking input and 64 neurons are providing the output. You can see totally 576. So like that, the same thing will be there. So from each and every input neuron that is connected to this next layer, next dense layer. So that's why the count will be increased. Here the output we are providing only by using one neuron. Since it's a classification based task, we are using only one output layer. Now you can see the total number of parameters, that is 2K parameters we are using, 2000 parameters. For this ML model, we are using 2000 parameters. If we clearly observe, or if we deep dive into these parameters, these total number of parameters will affect the output accuracy. How many more number of parameters that we take, how much great processing, or how much more accurate processing that we do, that much accurate response we got. So the total number of parameters are more, that means more number of accurate responses that we get. And one more thing here we need to observe here is this input shape represents the features, like how many inputs that we are providing. Currently this case, how many inputs we are providing? 8. So that is the actual shape right now. But in general scenario, we need to consider the training data related shape of 1. This 1 represents the total number of features. Whereas in this training data dot shape, it will provide, actually this x train dot shape will provide us the total number of input data set as well as the features. So how many features that we have, so that it will provide us. To make it clear, let's print that as well. Let's print x train dot shape, nothing but the training data, x underscore train dot shape. So it will provide you the two things. So let me rerun this so that we can able to see that data. So I'm just closing this histogram chart. Now you can observe here we're getting that. So totally 712 records are there, and those records are related to 8 input features. So here we need to specify the shape, like how many input features that we are providing to our model. So that's why we are providing x train dot shape of 1. So in this tuple, this value will be picked, that is 8 will be taken and considered as the input shape. So that's about input features. We are specifying the input shape as these many input features you need to take as input by using this input shape. So that's all about how to do histogram representation of the data, and how to see the summary of the model, and what is the input features. In this video, we covered these 3 topics. That is, we have seen how to tell our model these many input features are there by using an input shape. We specified that, and we also seen histogramic representation of data and summary of the model. I hope this video is useful. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching. I can see you back in the next video with another interesting topic. Until then, bye bye.